This is Jenny Kunkel, and in this video we're going to take a look at a few problems, go through and try to determine what normal form they are, and then how do we get them to 3 normal form if for some reason we are not currently sitting at 3 normal form. If we start, we have more abstract examples where we're going to use the generic table 1, table 2, table 3 as our entity, and A, B, C, D, E, F, etc. for our attributes. We have table 1 that has attributes A, B, C, D, and E. We have a line over C and D that indicates that that is a repeating group. We also have A determining B, C determining D, and B determining E. What normal form and why? If we would go ahead and say that it's 0NF, we would be correct, and that is because we have this repeating group C and D. Now, what does it take to get it from 0NF to 1NF? If we think about it, we need to go ahead and concatenate the key of our repeating group. So if we look at C and D and we look at our functional dependencies, we have C determining D. That indicates to us that the C is our key of our repeating group. Then we need to take a look at the rest of the relations in table 1, and that indicates that A determines B and B determines E, so therefore A is going to be the primary key of that unnormalized relation. And then if we try to write out what we have for 1NF, this is going to be table 1, and we're going to specify that A and C are the key by underlining those attributes. Then if we move to 2NF, we are going to be looking at removing any partial dependencies on part of the primary key. So our primary key is consisting of both A and C, and if we're going to remove partial dependencies, that means anything that just depends on A or anything that just depends on C. As we look through our functional dependencies, we can see that we have A determining B. It's not based on A and C. We have C determining D, not based off of A or C, and then we have B determining E. So with A determining B, then we have B determining E. We're going to move A and B and E into a separate relation. We can't leave this here because it's joined to B. And then we have C and D in a separate relation, and then we're going to have A and C in table 1. So when we get done, it's going to be 3 different entities that we have. We have our initial one that has our primary key here. We have our C and D, and then we have our A, B, and E. Then if we move to 3 and F, because we need to figure out whether we have already made it there or whether we still have more work to do, if we're looking at our dependencies, we have B determines E. Well, for our third normal form, we can't have anything in our entity that is not dependent on that primary key. And right now we have B determined by A, but E is not determined by A, it's determined by B. So we need to move B and E into a separate table as well. So then when we get done, we're going to have 4 different tables. We're going to have table 1 that's going to have A and C. We're going to have table 2 that has C and D. We're going to have table 3 that has A and B, and then table 4 that has B and E. Then our next problem, we have table 1. It has a primary key of A, and we have B and C. And we have A determining B, and we have A determining C. What normal form and why? If you said 3 and F, you would be correct. We have no repeating groups. We have a single attribute primary key. We have no determinants that do not depend on that primary key. Everything that's there depends on that A. So we are in the final state of 3 and F. If we go to problem 3, we have table 1 has a primary key of A, and we have B, C, D, and E in our entity table 1. We can see that A determines B, A determines C, A determines D, A determines E, C determines A. What normal form and why? Well, if you said 2 and F, there are no repeating groups, and we have a single attribute primary key, there is a determinant that does not depend on the primary key. So we're not 100% at 3 normal form because we have C determining E, and C is not determined based off of A. So we need to factor out that into its own relation. So to get to 3NF, we need to take care of this guy. And when we do that, we have C and E in our separate relation, and then we have A, B, C, and D in our first relation. Our fourth problem, we have table 1 that has a concatenated key of A and B. We also have attributes C, D, and E in the table as well. We have A, B determining C, A, B determining D, and then we have B determining E. What normal form and why? If you said 1NF, you would be correct. We have no repeating groups. We have partial dependency on one of the key fields. However, that means that we are in 2NF, and we need to take care of that. If we go through and take care of that, what we need to do is we need to factor out that partial dependency into its own table. So we need to move B and E into a new entity. We'll call that table 2, and B is going to be the key of that. We're still going to keep B in table 1, but we're going to remove E out of that table as well. So our resulting 2NF is going to be table 1 with A and B, C and D. Then for table 2, we have B and E. Then going to 3NF, if we look at what we have no additional dependencies, and we should indicate that we are in third normal form without any changes. Sometimes when we get to 2 normal form, we're at 3 normal form. Doesn't always happen that way. It all depends on our conditions for our data. Now, our problem 5 is a little bit different. We have table 1 with A, B, C, D, and E. We have A determining B, we have A determining C, we have A determining D, we have A determining E. We also have B determining A, B determining C, B determining D, and B determining E, and C determining D. What in the heck is this all about? Because we have 2 potential keys, and we could have 2 candidate keys, and at some point we make a decision between those 2 candidate keys, which one we're going to choose to be the primary key. And in this case, let's just go with A. Sometimes if we're looking at it, we might have a student ID and then a social security. Both are unique and cause uniqueness for a table, but maybe one is more private, and we would want to keep that private data private. So we would not indicate that that would be our primary key. We would choose the other one. So there are sometimes decisions made based off of what the data is. In this case, it's kind of arbitrary because we have these abstracts, so we'll just go with A. But if we look at it, what normal form are we in and why? Well, we are in 2NF because we have no repeating groups. We have a single attribute key, so we can either choose candidate key A or candidate key B. We also have C determining D. That's not based off of A or B, which would be the candidate key for that. So we know that we are going to be essentially sitting at 2NF, and we would just need to go ahead and take care of C determining D at that point. So if we go ahead and do that, we're just going to be factoring out C and D from this table relation. So we're going to leave in C, but D is going to come out. And we should see that now we have A, B, C, and E in table 1. In table 2, we have C and D. Now, one of the things to note when we have these candidate keys, in a lot of cases, we might want to set up a unique index if we did not choose one of the candidate keys as the primary key for a table in order to have fast access to that field because it is unique. Now, in this case, this would be just something that we would decide on when we go to physical design, that we might want to add it, might not. We're just kind of designating that that's a possibility at this point. Moving on to our last slide, we have problem number 6, and this is going to be a little bit more concrete. We have a student advisor relation. This contains an student ID, student name, advisor ID, advisor name, course name, semester, student ID determines student name, student ID determines advisor ID, student ID determines advisor name, advisor ID determines advisor name, course ID determines course name, and student ID, course ID determines semester. So what normal form do we have and why? If you indicated that we are in zero normal form because of the repeating group, you would be correct. To transition to first normal form, what do we need to do? We need to determine out of this what is the key of our repeating group. We already know that we have the STID, the key for our unnormalized relation. And if we look through all of our different course ID determining course name, we have the student ID and course ID determining the semester. That means that our course ID is going to be the primary key of that repeating group. And we're going to go ahead and underline those, and this is going to be our first normal form for our problem number 6, student advisor relation. And then if we go to transition to second normal form, this is where we need to take a look at our dependencies on the partial key. And if we have a partial key dependency, then we need to factor it into its own relation. In this case, we have student ID determining student name. We have student ID determining advisor ID. We have student ID determining the advisor name. Those are all things that are dependent on the student ID. The advisor ID is then determining advisor name. Well, we don't need to necessarily worry about this right now. It's going to be moved into the student. We have our course ID that's based off of our course. That's going to determine our course name, and then the student course ID is going to determine the semester. If we go to 2NF, we should see that we have the student course that's going to have semester there. We're going to have our student advisor. Now we've moved down the advisor name because when we moved down the advisor ID, we had to take this down. We couldn't leave it still up here because it's dependent on that advisor ID that's going to be in that student advisor relationship. So we had to move the advisor name down. And then we have our course ID determining our course name. So those are our 2NF. But are we done? Are we at 3 normal form? And if you think that we're at 3 normal form, we still have this particular relationship to deal with from the standpoint that we have our student advisor, and this has our student ID as the key. And when we look at our advisor ID, it's essentially determining our advisor name, which is not based off of the student ID. So that's going to indicate in 3NF, we're going to have to deal with that relationship. And then once we get that factored out, we are going to be at 3NF. So hopefully you understand a little bit more about how this works as we've gone through some of the problems. This is something that takes sometimes a little bit of time to understand. There are other people that just innately think that they see it. They should still go through all the steps to make sure that they're doing the design correctly, because it's not unusual for people to jump to a particular conclusion and it not necessarily be the right conclusion. So even if you think you know before you actually go through the steps, make sure that you're going through each of the steps so that you can get to the right solution.